problem statement is write a recursive function that produces all binary strings of n bit length. Here, let us understand the binary digit sequence first. Binary number means it will have only 0 and 1, right? You can't have more than 1 as the number. Suppose if the binary length is 2, then how many combinations we are going to have? 2 power n, right? Suppose the width of the binary number is 5, then we are going to have 2 power 5 combinations. If the width is 2, we are going to have 2 power 2, that is 4 combinations, that is 0 0 0 1 1 0 1 1. Like this, if it is 3, then we are going to have 2 to the power of 3, that is 8 combinations of binary numbers we are going to get, that is from 0 to 7. So our requirement is, if the user is going to give us the length of the binary number, then we are supposed to list out all possible combinations of binary numbers within that width. So first let us take the width of the binary number from the user. Before that, since we are supposed to write a recursive function, we are going to write recursive function to convert decimal to binary. Decimal to binary. This is a recursive function. We'll fill this function little later. Let us declare it first. It will take decimal number and then it will return a binary equivalent of this one. This is the recursive function. Let us write one empty return here. So this is the function. Let us write the main program now. In the main program, we are supposed to read the length of the binary number from the user. Since we are supposed to use this as a number, since input statement always read number in string form, we need to convert this into integer. For example, if the user enters 5, the input is going to read that 5 like this in the string form. That's why we converted it into an integer and then saving it in binary length. Next, we need to find out all possible binary numbers with that width. Suppose the user enters the width as 4, then 2 power 4 are the combinations. 2 power 4 is 16. You will get 16 binary numbers, each with a width of 4 binary digits. If the input is 2, then we are going to have numbers like this: 0 0 0 1 1 0 1 1. This is the combination. See, the number of digits are 2, so width is 2. So 2 power 2 is 4, so these are the combinations. So 2 power that width, that binary length will give us the number of binary combinations we are going to have. So let us remove this num. So binary combinations equal to power of 2 comma binary length. That is, if the length is 4, then this will become 2 to the power of 4. So these many combinations we are going to print in binary form. Let us iterate this in a for loop for num in a range of binary combinations. If you print this, you will get all the binary values, all possible binary values with that length. Actually, this is in decimal because here the binary combinations are, let us take the value as 3. Binary length 3 means 0 0 0 0 0 1 0 1 0, like that it will go, right? So here what is going to happen is these binary combinations will become 2 cube. 2 cube is 8. So this will become 8. So this will produce numbers from 0, 1, 2, 3 like this up to 7. So that this the total will be 8 combinations. So in each iteration, in the first iteration 0 will be assigned to num, in the second iteration 1 will be assigned until 7. In each iteration one digit will get assigned to this num. So if you print this num, you will get all these digits. Let us see this. Let us add some help message here. Enter binary length, and then we are going to read that length here. If you enter the binary length as 3, then we got 8 possible numbers, like 2 to the power of 3, right? That means 8. 8 means 0 to 7. Now our job is, we need to convert each and every digit into its binary form. Like for 1 with a width of 3, we need to convert it into binary. Binary will become 001, and this is 010, and this is 000. Like that we need to convert them into binary strings. Let us do that now. We have written a function here, right? So we'll call that function. This is decimal to binary. We'll convert each decimal number this range function is producing here into binary. Let us remove this print, and we are going to print this number. Now let us fill this function. Here each number will be less than 2, right? Binary number is either 0 or 1. So if the number is less than 2, we will return the number in string form. Sorry, this is decimal number. If the given decimal number is less than 2, then we don't need to do any further conversion, because it is already less than 2 means either it can be 0 or 1. So we don't have to do anything here. And in case if this is not less than 2, then we are supposed to convert this into binary. Let us assume the user given number as 5. So 5 means, like, what we are supposed to do is, first we need to divide this 5 by 2. That is integer division. If you do 5 by 2, then it will become 2. 2, right? If you do 5 by 2, this becomes 2. Again, we need to divide this 2 by 2. Then it will become 1. Then we have to stop there. So until then, we have to recursively divide this number by 2. Divide this number by 2 and then convert it into binary again. See, this is how we are going to make a recursive call. Here, decimal number, this is integer division in Python, decimal number by 2, and then if you divide that, then we will get some remainder, right? The remainder will always be less than 2. So we have to convert that remainder into string and then append it here. This is 5, sorry, not 5, decimal number mod 2. This mod operation will give the remainder. So this is how we are going to convert. Let us assume that the decimal number given by the user is 5. Okay, in the first iteration what happens is, decimal number is 5, decimal number is not less than 2, so this if block will not get executed. Then it will come here. Then we are going to make another call, decimal number by 2. Decimal number is 5, right? 5 integer division of 5 by 2 is 2. So this value is 2 now. 2, and then plus what we are doing here is decimal number mod 2. See, decimal number is 5, right? Decimal number is 5. 5 mod 2 is 1. So here 1 in string form. Don't get confused. This is not mathematical operation. We are adding a string form of because we converted that 1 into string. In the next iteration, see this decimal to binary, this became 2, right? This value became 2, and then it will come here 2 is not less than 2, so this will skip this if loop, and then again we are going to call decimal to binary with a value of 2 by 2. See, previous value is 2, right? We passed 2 here, and then the 2 will be divided by 2. This is integer division, so it will give 2 by 2 is 1. And this a string of decimal number mod 2 will become 0, right? Because now the this decimal number is 2, so this 2 mod 2 is 0 plus the value we have earlier. See here, the decimal number of 2 got replaced like this. The previous one we are keeping it as it is. Then in the third iteration, because we are not returning until we return, this recursion keep on going. So here now we are invoking this function with a value of 1. 1 means decimal number is less than 1, right? 1 is less than 2, right? So this gets hit, and here we are going to return. So what we are going to do, this decimal number str of decimal number. So now this str of decimal number is 1. That is the value of this 1, and we are going to add these two as we already have calculated them before. So what is the outcome here? The result value will be 101. So we got the binary number, right? For 5, it is represented as 101. So this 101 will, in case this num become 5, and we are going to call this with 5, this function call we are going to call with 5, and it is going to return 101. Like this, it will convert all the decimal numbers from 0 to that whatever max value. In case width is 3, 0 to 7 values will be sent to this, and it will convert them into binary, and it will return. We are going to print the return value. Here we need to do return, because then only the previous value will get appended to the current value. So this recursion is understood, right? Now let us assign this binary conversion into a number variable. Okay, let us test this. The binary length is, let us enter the value as 3. Sorry, we did not add print here. If you enter the binary length as 3, then take a look at this. We got numbers from 0 to 7. There is a small problem here. See, this is printing binary equivalent of each decimal number. No problem there. But we need to we need to fix the width as 3 for each number, because the width of the binary number is taken from the user. So whatever width the user enters, the user entered 3, right? So this should be written as 000, and this should be written as 001, like that. So we need to prepare, here it is 010, it is 011. After that we have 3 binary digits, no issue. So wherever we don't have enough width, we need to prepend that number with zeros. So how we can do that is, this binary number is in string form now, because this is converting the decimal number into binary string. So to prepend zeros wherever we need, we will use this zfill. Zfill of 0. Let us see this. That means what it does is, not 0, sorry, binary length. Actually, this is zfill means 0 fill. So how many zeros we need to prepend? It depends on the binary length. So if the length is supposed to be 3, then it will take care that every number is 3 in width. If there are less digits, then it is going to prepend them with zeros. let us enter the length as 3. See, now we got a perfect binary sequence now. Now let us give some other number. Let us say 5. See, now everything is 5 digits width. So this is the end of the program.